Now let us try the second example. This is an application. Given a bar of length 2 meter is fully insulated along its side, but the endpoints are exposed. It is initially at a uniform temperature of 10 degrees Celsius, and at T equals to 0, the ends are dipped into ice and maintained at a temperature of 0 degree. Solve the heat equation del U over del T equals to this to determine an expression for the temperature at a point P, distance x meter from one end at any subsequent time in seconds after T equals to 0. So I want you to pause this video and list down all the important terms that need to be listed before I show you the calculation. Okay, so what is the most important thing is given a bar of length 2 meter. So this is the length, which is L, is equals to 2. Okay, and then it's fully insulated along its side, but the endpoints are exposed. It is initially at a uniform temperature of 10 degrees Celsius. So initially, so means that when T is equals to 0, the value of U is equals to 10. So we can rewrite this as U x T equals to 0 is equals to 10 degree. And when T is equals to 0, the ends are dipped into ice and maintained at a temperature of 0 degree. So the ends at T is equals to 0, at the beginning, the ends are dipped into ice. So when x is equals to 0, U0 at T is equals to 0 degree. And the endpoint when x is equals to 2 at the end of the point of the road. Okay, from x is equals to 0 and x is equals to 2, U to T is equals to 0. Okay, now we have all these important terms, okay, where this is fx. Okay, so we have L is equals to 2, fx is equals to 10, and the last one is k square. K square here, where given del U over del T is equals to k square del square U over del x square. So for this problem, k square is equals to 1. Okay, now we can substitute this into Tn, and then from here we can get the solution of this PDE. Okay, now we get Tn, which is equals to 2 over L 0 up to L, which is 2. Fx is 10 sine n pi x over L dx. It will be 1, so we can take out 10 and then solve the integration, where sine will be negative cos n pi x over 2, and then differentiate things inside here, you will get n pi over 2, where the limit is from 0 up to 2. Okay, next, substitute x with 2 and 1, and I bring this to the front, where this will become 20 over n pi times with negative cos n pi times 2 divided by 2, which is n pi, minus negative will be positive cos n pi 0. Cos 0 is equals to 1, and this can be negative 1 to the power of n. So rewriting this, we get equals to 20 over n pi 1 minus negative 1 to the power of n. So this will become for n is equals to 1 and all the odd number, this is equals to -1. So 1 minus -1 is 2. So 2 times 20 will be 40 over n pi. And when n is equals to 2, 4, 6, this will be to the power of 2. We get 1. 1 minus 1 is 0. So this will be 0. Okay, next is substitute Tn into Uxt, where Uxt is equals to, so I just expand this where we get D1. I'm going to show you before the expansion. So this will be n is equals to 1 to infinity dn sine n pi x over L, which is 2 e to the power of negative n square pi square k square is equals to 1 times t over L square. L square will be equals to 4. Now we expand this Uxt. When n is equals to 1, this will be d1 sine pi x over 2 e to the power of negative 1 square pi square t over 4. And then the next one is when n is equals to 2. Next one is when n is equals to 3. And when n is equals to 4. Etc. Then we substitute d1, d2, d3, d4 based on this equation. So when n is odd, the value of t is 40 over n pi, and when n is even, the value is 0. So for t2, t4, and all the even value equals to 0. So if we write this, we get for d1, we have 40 over pi plus 40 over 3 pi and so on. So now we can simplify this, where this part is changing and this part where it is increasing with odd number or increasing with 2, and this is also changing and the others is remain the same. So we can simplify this. So we can factorize 40 over pi out, and the summation of n start from 1 to infinity, where this will be 1 over, since it is increasing with odd number or with 2, so we can get 2n minus 1 sine 1 over 2, 2n minus 1 pi x times with e to the power of negative 2n minus 1 square pi square t over 4. So this is the solution of the PDE where u at t is equals to this. So we can identify what is the temperature when x is equals to any numbers, any constant, okay, and when t is equals to any time. So if you plot this, you can get the temperature distribution along x with respect to u. So it means that the graph maybe shows something like this. So meaning that at the middle of the rod, the value of temperature is equals to this. So that is the meaning of this solution.